So I'm going to go ahead and switch things up here a little bit. And instead of me, the facilitator, the host of this keynote conversation session, I'm going to go ahead and ask actually Eric to introduce Kat. I'm going to go ahead and ask Kat to introduce Eric. So Eric, you want to go ahead and kick things off here?
Yeah, you bet. Hopefully everybody can hear me okay. Kat, first of all, thank you for hopping in here at the last moment to give us another set of eyes and perspective on some of the conversations we're going to have. So this is truly as ad hoc as it gets, folks, where we're just kind of with some fairly last minute notice going to bring some content to you. I first met Kat, I want to say it was back in, 2017-ish when Sec 540 was, I think its second beta. I want to say it was in Washington, D.C. right around Christmas time. And we all kind of just sat in this room and looked at all of these different AWS kind of security and automation related techniques to start figuring this whole cloud security thing out. Relatively new at that point in time. And I remember Kat and myself and Ben Allen, who was also there for that event, having a lot of good conversations about just the cloud and the different security problems that eventually we were going to have to figure out. Kat's done an amazing job going forward with that, especially with her previous role going into GCP and all of the different nuances inside of the Google Cloud platform. It kind of was perfect as we hit the pandemic in 2020. Kind of the student in Kat's situation ended up turning into be my instructor. I think that summer, what else are you going to do during lockdown? Then Kat and I did several Zooms going through GCP and security and identity inside of GCP, kind of really digging into that. And Kat has turned into be one of the leaders, somebody that I kind of go to for information now when I'm trying to dig into that platform and figure out things that are going on and why they happen that way. So lots of great research coming out of Kat and the Cloud Security Forum. I don't think that's come up yet, but that's a great Slack workspace, more long-lived, that you can jump into. And Kat's posted a lot of great research and things out there. Also been really fun to see Kat work on a brand new SANS course that's going to be eventually launching later this summer. So she's put a tremendous amount of effort into what is going to be Sec 549 Enterprise Cloud Security Architecture. So I know how much work goes into that. And Kat, I know you're very much looking forward to getting that out the door for folks to get some feedback on it. So that's at least snapshot of what the last 5 years or so. I'll pass it over to you at this point.
Yeah, thanks, Eric, for the introduction. You were right. We first met in 2017 at SANS CDI. If anybody has the opportunity to go to a SANS summit in person, I highly recommend the CDI conference. It's usually the second week in December. It's one of my favorites. Christmas time in DC is just wonderful. It's not too cold, all the trees are decorated. It's just kind of like Christmas time at its peak. It's my favorite. That was always my favorite conference to facilitate. And that's where I first met Eric. And Ben Allen I facilitated for them for the at the time, it was called the Dev 540. Now it's the Sec 540, but all about how to use security, how to use automation in building out secure code pipelines, for which Eric is the lead author of that course. And then I worked with him later on, a few years later, on the Sec 510, the secure assessments across all of the three major platforms. Worked with him a lot on the GCP IAM specific things. So I've gotten some chances to work with Eric over the past few years on, first learning a ton from him on how we can leverage automation. And then, when I think about Eric, I think also a lot about his work in the serverless space. I was just looking up his project here, Serverless Prey. That's a project you put out, 3 years ago on a tool set to use across all three major platforms that will allow you to inspect the runtime of your serverless functions, your Lambdas, your GCP functions. It will allow you to inspect that environment. So when I think of Eric, I think of security automation first and foremost, preaching infrastructure as code, preaching, the only way we can manage this ball of complexity is to codify it in code and automate the heck out of it. And when I see Eric, I also think of serverless. I think of like providing the community with the tools to see, is serverless really serverless, and what the heck is going on when you throw a function up in the cloud and you provide it a runtime. So yeah, if you've been around the cloud security space at all, I hope you've run into Eric. If not, here's your opportunity to.
Hey, great introductions here. I think, I'm going to make this more of a habit. Eric reminded me that we tried this a long time ago as well, and that just shows, the lack of depth in my memory here. But I'm going to do this, if I host a dinner party at my house, I'm going to force people to introduce other people as well going forward, right? I think it's a lot more fun. So again, we are going to be talking about architecture, automation, and identity related topics, not necessarily in this order in this session here today. And if I go ahead and move forward to the next slide here, right? Whoops, I'm a little click happy here, right? Now, from an architecture perspective, you've got this beautiful house that Kat had found an image for. And it makes me reflect back to when my wife and I, we've done a lot of home remodeling and things like that. And earlier in our lives, we did a lot of the work ourselves. And, it turned out fine, actually. But, our first house where we did the vast majority of the work ourselves, we didn't have an architect, right? We're like, nah, well, we know what we like. We can just figure this out ourselves. And looking back, even though it looked fine, if we had an architect, they probably wouldn't have said and allowed us to have both redwood, maple, Douglas fir, 3 or 4 different types of wood, all visible within the same living space, right? And it's like when you don't have kind of architect, and Kat and Eric have both worked as architects designing and architecting systems and systems in the cloud, things can go a little bit awry. So Kat, we'll go ahead and start with you. Can you tell us a little bit about kind of what you think about when you think about kind of architectural complexity and how this relates to the cloud?
Sure. I mean, I think, complexity gets a bad rap. I think because of the phrase, complexity is the enemy of security. I think that, in any system that gets sufficiently sophisticated, complexity is going to arise. So it's not necessarily that because you've encountered complexity in your system, that means you've done it wrong. It just means that maybe you're managing a very large system. You're managing a very, very complex system at scale, and complexity arises. So we use architecture to help make sense of the chaos, to help bring order to the chaos, and to help tease out those flaws, to surface the flaws earlier in the process when it's cheaper.
Yeah, great. And Eric, I know you've had a couple big engagements, basically putting together an architecture for organizations that are moving to the cloud, for a lot of workloads to the cloud for the very first time. When you signed up for that, in terms of those engagements, what did you kind of think going in? What were the big lessons learned after the fact in terms of architecting these environments from scratch?
Especially when you visualize how things are going to turn out. So you think of that lift and shift mentality, and how applications that weren't designed to run in the cloud run on-prem. You always think it's going to be easier than it really is. So I'd say, first off, if you think you're going to do this, probably just double or triple what your estimate is for how long it's going to take. Because, as I look at the way that this treehouse looks, as you look at a traditional monolith system, most of that complexity is kind of built inside of the application stack, where we've got all of this kind of logic that's mostly just compiled up into all these binaries So from like a networking and a sysadmin or a cloud admin perspective, you're not really being exposed to that much. And as you look at the evolution of going from a monolith system to more of an API driven ecosystem, maybe something that's kind of more cloud native, right? That you might run in a container or run inside a Kubernetes, you start to expose the internals of these big monolith applications a little bit. And a lot of the design decisions that were made originally, hey, we're going to just run on this instance that lives forever, suddenly have to be dealt with. And we talked a lot about the pets versus cattle conversation in that keynote yesterday. And that's kind of the big takeaway that I've learned on some of these engagements is really it takes a lot from the dev side to move from the monolith to the cloud native mindset to get there. But if you can cross that bridge and you actually need to establish some interconnected systems in order to get to the point where you can apply a good cloud architecture, in my opinion. Because if it's just one public IP in this big monolith system, you really can't use a lot of the cool security controls and a lot of the good cloud architecture techniques that we've learned about and that we now have at our disposal. We're kind of under leveraging the cloud if we truly just lift it, shift it, and run it over there.
Mm-hmm. Yeah, James has a really good comment in Slack. So security architecture helps to reorder the chaos, and chaos engineering helps to stress test and make a system anti-fragile. And anti-fragility is a concept that came up in the keynote yesterday. And probably one of the best examples, historical examples of this is, Netflix's Chaos Monkey, right? In terms of purposely causing regional outages, system outages, and so on. Kat, what do you think about this kind of concept of chaos engineering, which is still in its relatively early days? How would you kind of incorporate that into your work?
Well, purposely taking out systems, which I think is the chaos monkey, idea is that they purposely take out systems to see, how are we going to recover if we're just sort of like randomly taking out systems. I look at that sort of at the far end of the maturity spectrum. So I don't want anybody to have the impression that, you're going to do this on day one or day two or day three. But speaking more to the idea of building in resiliency in a system, I mean, that should be top of mind. That's a key component of systems design. For the last, 40 years is building in resiliency to your systems. How you decide to test that, whether it's through, a chaos monkey or some more of a controlled tests. Well, that's going to depend on where you are in the maturity level.
Great. Hey, Paul has a really good question here, and this is related to something that we were originally planning to have a slide related to a little bit later on. But Paul asks for this question for both of you guys. Any advice on bringing developers on board? Is if you've got some legacy workflows, you're encountering resistance, right? Some of this friction that we were planning to discuss later, isn't DevOps in everybody's interests? What's going to help? Is it training? Is it something else to get them on board, right? And how do we in security do this without seeming like we're causing more work? What do you guys think?
I talk a little bit about that in the course that I'm writing now about ways not to create friction specifically with higher level guardrails. We're always wanting to have these like higher level controls on our cloud environments that say, thou shall not do this and thou shall not do that, to prevent developers from, opening ports and, complying to the standards. While that's good, and we want all of those, controls so we can, have some safety blankets at night, it also provides a lot of frustration and angst if a developer is trying to do something and they're just like blocked and they don't know why. And the only thing I can think of is transparency, right? Make it extremely clear what the rules of the road are, and then make the process for requesting an exception extremely transparent, right? Have the ability where if you have the need for an exception, a workload that doesn't fit within your mold, that is well documented and everybody knows how you go through that process to get into an OU, to get into a folder where you don't have those constraints upon you.
Great. Hey, while we mentally bookmark that topic here, because there's still a lot to talk about there, I'm going to go ahead and move on to the next slide here. And a number of people have commented here about architecture, and actually, Prasanna, I don't know, somehow maybe you saw the next slide already. I think I had accidentally gone ahead. And exactly, the cloud providers themselves provide what they describe as their various well-architected frameworks. And these well-architected frameworks, at a high level, they're all basically the same. They all have different pillars in terms of availability and resiliency, things like that. But they all also have a security pillar, as you can see here. Now, the specific details might be a little bit different here in terms of how they describe certain things. Microsoft and Azure tends to be a little bit more verbose and a little bit more process-oriented in some cases. But at a high level, these well-architected security pillar frameworks are all pretty much giving us the same guidance here. And Rich mentions that the job of the security architect is to try to manage and facilitate complexity. Now, Eric, given what you know about these well-architected frameworks and your experience here, kind of what would you say, why are these helpful, but then also what is missing from these well-architected frameworks?
I mean, these are good frameworks to know about, and I would say we should be reading through them and understand, some of the key setup things, like we'll probably get into this later, but you have to have some of these prerequisites covered, in my opinion, to use the cloud securely. So single sign-on, how many times does that come up where we're not creating local users and we've got actual user integration through, whether it's on-prem AD or maybe it's through, Google Identity or whatever. But single sign-on and some of the best practices for setting up IAM, and also some of the best practices that we looked at yesterday, such as, cloud workload identity and things like that, for actually eliminating those long-lived access keys and secrets and so on and so forth. Those are really important concepts that need to be in the architecture. And the GRC side, we know that that's going to come up at some point. So figuring out how we're actually going to monitor things and how we're going to get visibility into the workloads that are running, I think that is critical to understand, as well as Kat's already mentioned kind of, OUs and folders. And we talked about that org architecture a lot already in yesterday's discussions. All of those things are absolutely must-haves to do this correctly. Some of these I do think are missing a little bit on the kind of how to let the development teams operate without having that friction that we just talked about. And a couple cool projects. I know GCP's got a Terraform repo, and I'll post a link out here, but it's actually pretty neat. It's for their, security foundations or their best practices framework. And, they go through this whole thing, but then they say, hey, look, here's a Terraform repo that you can just use and you can run it, and it'll just bootstrap your entire GCP organization to apply. It's pretty prescriptive, but it'll apply what they think is their well-architected organizational controls. So I think that's the missing gap in a lot of cases, is how to get from this 30 to 40 page PDF to actually doing it or actually getting it set up. So kudos to the folks at GCP for setting that up.
Yeah, before I go to Kat here, I see that Ash has a good question here, is in terms of talking a little bit more about GRC, governance, risk, and compliance. Sounds like, Ash, in some cases, you've got some pushback from leadership in your organization because GRC is not necessarily security. Now, at a very high level, what is our job as cloud security professionals, as security professionals? Our job is to not just implement new controls, right? Deploy new features, new security capabilities. Our job at a very high level is to manage information risk for the organization overall. And if we remind ourselves of, well, what is risk, right? I think we've all seen that equation. Risk is impact, how bad could something be, and likelihood, what is the chance that something bad will actually occur? Well, that likelihood further breaks down into, right, the vulnerability, the misconfiguration, the vulnerability that exists, coupled with the threat actor itself. and we implement controls to kind of try to manage that risk. And as you can see, right, from the GCP pillar here, manage risk with controls, Microsoft mentions something along those lines as well. And really, I think it's more of a question of, Ash, in terms of kind of framing that in the appropriate way. Part of that, moving on to the next slide here, is related to what Eric was just talking about in terms of identity, and Kat talks a lot about organizational units and architectural guardrails. And Kat, when you see something like this, what do you recommend to an organization? Because John mentions that, you know what, these high-level frameworks are good for Greenfield type of environments, but hey, what about when you've got an existing whole infrastructure, let's say already deployed in AWS, or you've got a hybrid environment? You know, how should you be thinking about your identity perimeter? How should you be thinking about your application or data perimeter and the corresponding guardrails that you want to put in place?
Yeah, I think John wins the comment of the session so far, right? He said that frameworks are splendid for greenfield environments, brownfield, hybrid, migrations from on-prem. They don't necessarily fit as well. And this is a perfect example where we have what might be sort of like the ideal state as prescribed by AWS well-architected framework, where you have an organization with your management account at the root node, and then you have these, you know, nicely organized OUs, and that, that perfect organization will be a business's end state. Their path to getting there, their phase of migration, might take 2 years, 3 years, 5 years. They might never get there because of acquisitions and mergers, right? So there's always going to be this need for a transitional state. An OU, or kind of a walled off portion of your cloud estate that for various reasons can't fit within this idealized state, within the idealized guardrails that are enforced top down or enforced at the OU level. This transitional portion of your estate that has a migration plan, hopefully. There's different techniques that you can provide to de-risk some of the applications. You can peel some of the riskier stuff off, but really has to be treated as your intake zone for moving stuff from on-prem to the cloud, or bringing in acquisitions and mergers, places where you need to, where they need to kind of just chill for a little bit before we can uplift them.
Yeah, it makes a lot of sense. I mean, you're basically saying, hey, it needs to be tied back to what the organization cares about. What are the objectives, the business objectives here? It's not just about moving to the cloud as much as we'd like to just geek out on just the technology itself. And here we've got on the slide an example from the AWS Security Reference Architecture. Now, we just mentioned the well-architected frameworks on the prior slide, and those are very high level, talking about some principles and best practices. Now, the AWS reference architecture gets into a little bit more specifics. Now, normal architecture diagrams, and earlier Karsten mentioned kind of hub and spoke and different approaches and so on. Usually you might have a logical architecture, an application architecture, and you would inject security controls at the appropriate points. Now, what I find very interesting about the AWS approach here is they said they've kind of flipped it on its head. And they said, you know what, we're not going to take an existing network architecture diagram or logical architecture diagram and inject the security controls, which is still a valid approach. But they say, look, we're going to put the security services first. Now, to be honest, this is a little bit of an advertisement for various AWS security related services. But putting the security design front and center, right, like this, in terms of how do you break up the different organizational units into security infrastructure, your application workloads, and so on, right, I think is pretty useful. But the question naturally comes up is, how do we actually get to this point? Now here, in terms of automation, we've got an example of a cloud infrastructure as code pipeline. Eric, do you want to maybe help the audience walk through this a little bit and share what they're seeing here?
Yeah, so this is really the first problem I solve whenever, and this is kind of whether we're walking into an existing cloud or we're building a brand new org out, is the first thing I'll do is create the deployment pipeline. So there's nothing in this cloud. We'll have to go, I think there's some prerequisites here. You've got to go set up single sign-on and a couple other things so you can actually run a pipeline and do something. But the idea that of this cloud infrastructure, which I know we've got several sessions today that are going to help us further illustrate this, is you've got a version control system with our Terraform in it, like Kyler showed us yesterday. We're actually controlling that S3 bucket, and we're going to leverage version control. So think of GitHub or GitLab, which Magno is going to jump into what maybe this YAML file could look like for doing this here in the first session. And it's really going to control the releases or updates to that entire cloud infrastructure. So your primary kind of question you need to ask yourself up front, and Kat, I'm curious what your opinion on this is do you put dev, stage, and prod, your actual environments, into completely separate orgs, or do you isolate them kind of with that OU boundary and then share maybe security and maybe a DevOps account and some of those things within the same organization?
Yeah, is that a question to me?
If you want to jump in, I've done it both ways, and I know there's pros and cons of each. I'm just curious if you had strong opinions one way or the other.
I mean, I do. I generally see, separate OUs being maintained for dev and prod, not separate organizations. Mainly because you want to be able to enforce your policies at the OU level rather at that higher level, at that management level.
Right.
So if you're consistent about where you apply your policies at the OU level, then all of a sudden your OUs can be a sufficient boundary, and then all of your accounts can follow beneath it. I don't see that there's an advantage to doing separate organization for a dev or a stage, unless, like I said, unless you're placing your policies at the management level, the management account level, in which that's an easy fix. Just drop it down a level.
Yeah, that makes sense. I guess regardless of how you set it up, what we would ultimately do is that Terraform apply command, which is going to go in and apply the configuration for all of the different accounts you're seeing on here, is going to be your only way to get into a right state in that cloud account. So the idea is we kick the humans out, everybody's view only. Maybe you can go create some things in that sandbox account that we kind of talked about yesterday a little bit. And that's where we can go play around and test things out. But if it's a real account, we can't go in there and change anything. It all has to flow through the infrastructure code and the scripts. So we have full control over what that environment looks like and prevent desired state configuration kind of drifts away from what we think is actually going on in the environment. So I think that concept really feeds this slide. It's how you can make sure that everything is set up the way that it's supposed to be. And then each individual development team, if we look at the one little application account that's on this slide, every dev team might have their own pipeline that actually deploys workloads into the resources that have been pre-configured there. So it's going to require multiple teams and multiple kind of pipelines to work together to build this stuff out. And it kind of goes back to that original concept of security and dev and ops. You're hearing that DevSecOps phrase a lot, are going to have to work together to get all of these things working.
Hey, we got a number of good comments here in chat, and Kat, it's pretty impressive that while talking, you are responding to some of the comments here as well. But related to exactly what you guys are saying, and Kat is going for a single sign-on. We've got a question from Artem. What's a better way of managing these different accounts? Is it using SSO, or is it using assume role for access to these different OU accounts? Kat, you want to expand on that a little bit, and then I'll turn it over to Eric.
Yeah, so I think the question was, just about like, how do you access once you have this like multi-account strategy, you might have dozens, hundreds, God forbid, 1,000 AWS accounts, and like, how do you manage access? And AWS makes it, fairly straightforward to manage this like one-to-many relationship where you have a single user and that single user needs to access many accounts. And it's through their identity product called AWS SSO, which automates the process of end users being able to assume roles into all of the member accounts in the organization, as opposed to having to manually set up that process. AWS SSO kind of automates the creation of roles into accounts and automates the creation of trust policies. So like the mechanism is the same as before AWS SSO. You're still assuming roles into accounts, but we have this very nice interface through AWS SSO, which makes it pretty slick for the end users. And there's really no muss and fuss of setting up the roles and trust policies.
Yeah, there's another question here in chat from a little while ago about kind of, hey, how much should the architect be involved in terms of kind of redundancy? And Eric, we just ran into a situation where we've got multiple clusters for redundancy, best practice, and so on. But effectively, the cost was, doubled in that particular case in terms of an expensive gateway. It's like, how do you think about what those trade-offs are in terms of kind of, well, hey, redundancy, reliability versus cost and other factors?
Yeah, I maybe am a bad resource to ask about redundancy because usually I'm the one building the things and not the one paying the cloud bill when it all comes down to it at the end of the day. And the clouds love for you to be completely redundant. I mean, we've set up some environments for folks that are spread across 3 availability zones inside of AWS, and we've got 3 different containers running, and and then we had to set up, going back to kind of the chaos monkey conversation, we had a big script that ran, and it basically put in NACLs in one of the AZs in every single subnet and basically started blocking all network traffic to prove that if one AZ went out, we still had high availability across the other 2 subnets that were in there. And it's pretty awesome how you can set that stuff up. And architects, I think by nature, that's how we would want to do it, right? But the cost aspect to this, is it really worth it? I mean, what are the chances that one of the AZs are actually going to go down? And do you still need redundancy there? It's an interesting conversation. So I think the cost aspect is a lot of times kind of ignored in these architectures, like you mentioned, promoting the security services, right? And usually you're kind of surprised by the bill at the end of the month rather than trying to project costs and figure out, do we actually need this, based on the requirements, et cetera.
Yeah, great. A couple other good comments here. Steve mentions that in terms of the pipeline, right, that we see an example pipeline here on the slide. The big advantage from security is scanning new infrastructure, scanning new code as part of the pipeline itself. And as we do this here, in terms of one key thing is, hey, we want to make sure that those scans are quick, fast, right? Give you high fidelity results. Main thing is you cannot slow down the pipeline, and that's how we can help move into a position where we can be DevOps and engineering's friend. Now, there is another question here, though, that in terms of migrating existing cloud deployments to infrastructure as code, and Hugo mentions this, and I'm presuming maybe the prior infrastructure was stood up via the console and not via code, not via CloudFormation or Terraform. How would you recommend that you start moving some of that stuff? Full conversion, certain specific resources? What would be a best way to go from that kind of nothing as code to a infrastructure as code scenario?
What do you think? I'll let you tackle first, and then I'll tack on to it.
Oh, this is all you, Eric. No, the codifying resources code and how much time and effort to invest when you may have built out a whole system on the console. That's you, Eric.
Well, I've done this in the last 6 months for an account that had a bunch of stuff in it. And this is the path that I took because I think it caused me the least amount of grief is I didn't actually try to import anything. The clouds make it really easy to just whether it's DNS, using kind of an alias record to old load balancer to new load balancer, they make it really easy to just shift traffic from one thing to the other. So rather than try to import it all and get the configurations perfect, which often is just a lot of Terraform import commands and things like that, I ran something like Cloud Query against I'll call it the pet account, right? Got my inventory and said, here's what I need to do. I spent a lot of time running pipelines to build up an entirely new AWS account with all of the things in it. And I deployed the workload on there and tested it, make sure everything was good. And then I just flipped the DNS entry and said, let's roll over to the new environment. And we just closed the old account. So that's how we did it. And I felt like that was my easiest path rather than sitting there trying to import a bunch of pre-existing things that I already knew didn't fit my desired state.
That makes sense. So you did a hybrid approach. You did like an initial scaffolding of what are the high level basic things I need to create and use that as a template to then recreate in Terraform, hopefully rewrite them to better suit your needs. Use it as an opportunity to revise and refresh the infrastructure.
Yeah, because they change services all the time, right? When this account was created, let's just say that like shared VPC and maybe some of the hub and spoke things weren't really available. So as I'm staring at this kind of isolated VPC that we've got, Nessus scanners and all this stuff running inside of, that there's a better way to do it now. It's an opportunity to say, all right, let's build the 2.0 environment. Let's use our centralized networking account and use shared VPC so we can actually just share it out with this new workload account. And then we've got, flow logging and a lot of those security controls already turned on, and they're part of the paved road at that point. And then we'll just roll the workload out into it. So it gives you an opportunity to kind of brush up and improve things along the way as well.
Great. Hey, the last thing related to this particular topic before we move on to the very last slide, the next slide here, which is the last one, is Lorraine has a good question is, hey, what are some of your favorite resources for, I think, learning DevSecOps, labs for doing DevSecOps and so on? Eric, you want to take that one real quick?
Yeah, so going from the ground up here, I typically learn best just by picking my favorite open source project. So I don't know how many of you out there have used like the OWASP the Juice application or something like that. It's kind of a vulnerable demo app, something like that. And what I'll do is I'll fork that into whatever, tool chain that I'm wanting to learn about. So it could be GitLab or it could be GitHub. And then I'll start just writing up some YAML that might, deploy that out to kind of my fake cloud account and things like that. I know there's tons of training options out there, but the way that I learned, I typically just start from some open source project that's close to what I want, and then kind of customize it from there. I know there's some really good cloud security ones. Kat, I'll let you kind of cover those, just the cloud sec options that are out there too.
Yeah, I guess I'm similar to you, Eric. I learn by doing, right? So I, maintain my own GCP org, my own AWS org. I kind of, have my own, I cloud admin myself, right? So you can learn a lot about the cloud by just having to maintain your own infrastructure and think about, well, how am I going to not get billed for all of this? I have to set alarms and set restrictions to spin down resources if we hit billing thresholds, and and then deploy open source projects. I'm a huge fan of Kubernetes Go, which you'll be hearing about later today. So kind of playing cloud admin on my time off has taught me a ton about maintaining cloud infrastructure just by having to do it on my own, by having to maintain my own infrastructure.
Yeah.
Great.
And that's how I learned with it too. It's take that, whatever your app is, and give yourself a goal. Like, I want to get this running in GKE and be able to browse to it on the internet and accomplish that task. And you'll learn every single intricacy that goes along with doing it.
And because it's the cloud and your credit card's attached to it, it's a little scary. So you have to learn about, setting billing alarms. And because it's the cloud, it's a little scary. So you have to learn about VPCs and security groups and private access. And there's plenty of things to learn about if you want to set it up, right.
Awesome. Hey, we're going to go ahead and move on to the very last slide. So on this next slide here, centralization versus decentralization. And this kind of came up already here in terms of the friction that might be introduced. Is sometimes we in security feel like we want to tell the engineering team, tell the DevOps team what they need to include in the pipeline. Now, I'll say up front, hey, that would be the wrong way to go about doing it, right? We need to make sure that our security tools in the pipeline run fast, run efficiently, give high fidelity results. But in terms of this centralization and this concept of decentralization, Kat, I'm going to ask you to talk a little bit about this in relation to, you just published some really cool research, in the last couple of weeks or so, related to cloud native ransomware. Can you go ahead and talk about that?
Yeah, so I just published that last week, a paper that went out. It just walks through, a hypothesis on, what would happen if threat actors were to leverage cloud native resources to affect availability. And so the scenario that I brought up was using KMS to lock out a customer, an AWS customer, from their S3 data. So preventing access from a KMS key, either by restricting access to the KMS key or using an external KMS key. So going through this kind of like, thought process of, well, how would this, ransomware attack happen? And then what are the patterns that, and patterns and guardrails that an organization could employ to prevent this or to make it really hard? And I think about things like centralizing our keys. So the scenarios that I laid out in the paper all had an attacker taking advantage of either a KMS key that they could use externally, or a KMS key where they could create their own KMS key and use it to encrypt S3 data. But with a strong centralized pattern of KMS keys, an organization knows exactly which KMS keys should be used for encryption. So if an attacker all of a sudden brings in an external one and attempts to use that to encrypt data, we can write an SCP to prevent that. If an attacker all of a sudden creates their own KMS key and tries to use that for S3 encryption, we can write an SCP to prevent that, because the groundwork has already been done to create this centralized pattern that knows exactly which keys should be used for encryption and where they live.
Yeah, very cool. Makes a lot of sense, which is also related to something that came up in the session yesterday in terms of kind of this evolution of our various controls. And ransomware, by definition, is related to, well, how do we actually recover from various issues from what the adversary is doing? So yeah, that makes a lot of sense in terms of needing to understand this in terms of the overall, how does this fit into the architecture of not just the protective controls, not just the process automation, but in terms of making things more resilient, as other people were saying here as well. Kat, you have, I can't see, oh, great, Eric, thanks. You posted the link to Kat's post here. Yeah, thank you very much. Wow. Now, I kind of lost track of time here, everybody. We are at the top of the hour. I think that there might be some questions that we didn't get to here in the Slack channel, but I want to go ahead and thank you guys for Eric and Kat for sharing your knowledge and your experience here with everybody, and for the great conversation. Hey, we'll go ahead and move over to the Slack channel here to do some follow-up if needed. And we're going to go ahead and now take a 15-minute break, and before we come back for our next session here. So everybody, let's give Eric and Kat a virtual round of applause. Thank you guys very much. See you at the next session.